Lovely to see everyone tonight. And as Jeremy was saying, I'm going to talk about my experiences with teaching LilyPad Arduino and just a bit about me. I'm a PhD candidate at Goldsmiths in the Department of Computing, and I make wearable technology, and I'm really into sensors. I use various sensors to make mischievous wearable tech in the form of like EEG pendants, a barometric skirt which changes colour depending on where you are and also feeds in physiological data from your body. I've made a temperature sensing shirt which lights up if you get overheated in social situations, and a heart rate detecting necklace which starts flashing when someone comes into your space and flashes your heart rate. And here are a few examples of my work. I won't go through them all right now because we don't have time. And I'm going to talk about LilyPad Arduino in particular. So I've done quite a few workshops teaching all sorts of people. So I teach at Goldsmiths, where I am a student. So I'm not going to talk about that tonight, but I teach LilyPad Arduino there. And I also have done modules in interaction design. What I am going to talk about is my experiences teaching in the community and school kids. So the LilyPad Arduino, if you don't know, it's one of the Arduino family, and it's sewable, which makes it a bit different from the rest of the Arduino family. And you can use conductive thread to sew it to sensors and actuators, things like LEDs and stuff. And you can also solder it if you want to, but it's not necessary. So that means that basically you can use it with like textiles and fabrics and materials to make like garments, accessories, home furnishings if you like, also toys and all sorts of different applications that use textiles. And as it says on there, it's open source, otherwise I wouldn't be here tonight. Has a good number of inputs and outputs, both analog and digital, and it's a really great vector for encouraging boys, girls, artists, designers, adults, all sorts of people to kind of get involved with hardware hacking and making things. It's a really approachable design. It's round, it's purple, it's attractive, so it looks good, you know, whether it's secreted inside a design or sitting on top. Things that could be improved, because there's always things that could be improved. It's not cheap, so I tend to reuse mine. I'd like more modules to go with it. There is a suite of modules and sensors and actuators that are sewable you can use with it, but there's always room for a few more. An industrial version would be great, I think, just because sometimes I'm limited by the amount of current that I can put through it, so that limits the amount of sensors that I can use, just because it only likes to work with a maximum 5 volts. And more competitors would be great as well, just to drive the price down and get a bit more innovation. So that's what it looks like. Basically, it connects to your computer via serial USB, via FTDI board. This little diagram here is just one that I made that just shows you the pads themselves and where the digital pins, analog pins, etc. are. It uses an Atmega 328 IC in the middle. It has a reset button and has an assortment of pins. I won't go through them all individually now. So, as I said, it's a sewable microcontroller PCB, and when I use it, there's a little bit of hacking that I do with some of the components, and this just shows you briefly some of the ways to get around using traditional components. So basically for sewing, tend to like use a little pair of pliers to twist the anode and cathode pins on like, for example, LEDs and stuff. And that makes them easy to sew, and that's an example of a spool of conductive thread there. So in the classes that I teach, I tend to teach the basics of coding and like hardware. So some of the stuff I talk about to kids and adults is like the difference between analog and digital, which is really important when you're thinking about making a project. Just some of the other simple things like being able to tell anode and cathode, but also being able to actually look and see on the LED, because it's not always very obvious, even though you're always taught that one leg's shorter than the other. It's not always the case. I also show students how to use fritzing, for example, to make circuits, and Ohm's law, which is always very important when you want to work out voltage in your circuits and resistance. There's a nice list there of some of the other stuff. And I also show students how to get started with the IDE, the Arduino coding environment, things like how to compile, upload, how to save your sketches and files, but also some of the basics of coding, so functions, variables, etc. And I tend to teach by examples. So these are some of my screenshots from my slides. So I just kind of try and point things out and make them really obvious, so that people can go back and look at them. And so some of the workshops that I've led. These are some screenshots, which you probably can't see these very well, but I ran a 3-day boot camp at Aberystwyth University for kids from the age of 8 to 16, and we went through several breadboard examples, which is in here, but we did things like parallel and series circuits and stuff, and we moved on eventually to using fabric with the LilyPad Arduino. And the students at the end were encouraged to make their own designs, and although some of them are here are a bit hazy, but they came up with their own circuits, which was really rewarding for them, because up till then I'd been kind of directing them into into different kind of ways of using circuits and stuff, and showing them like concrete kind of examples of coding and stuff, and getting things to blink and LDRs and switches and stuff. So it was really rewarding at the end to let them loose and let them make their own circuits. And these are just a couple of examples. Another workshop I did, which was probably for about 300 students in the end, and I did this with my friend Sophie McDonald, who's part of MISTech, by the way. We made 2-hour workshops for 8 to 16-year-olds in Wales, and we went around schools, and some of them came to us at Aberystwyth University. And because we didn't have time for them to go through the whole breadboard and sewing experience, because I found that it takes quite a lot of time to do that, so you need like a couple of days to do that, and because we were only doing really like morning or afternoon sessions, we made these e-textiles pieces, and we chose the Welsh Dragon because we were in Wales, and what we did was we pre-sewed these with like LDR and switches and blinky lights, and we sewed the LilyPad Arduino into them so that the students could plug straight in and play with the code. So they got the experience of playing with the hardware, but not having to spend time putting it all together and sewing it. So that was another approach that we had. And as you can see here, these are just some shots from some of the classes that we went to in Cardigan and Aberystwyth. And the local MEP came to visit us with the Vice Chancellor of Aberystwyth University. And that's me and Sophie McDonald meeting the MEP, who was very interested to hear about open source and Arduinos and teaching. And a final example is an introduction to wearable technology that I gave at Hebden Bridge Hackspace last year. And this was a mixture of all ages, genders and experience with Arduino. So it attracted a 50-50 gender split, which was great. And what we did during that day was we did some experimental circuitry with the LilyPad Arduino. We did an LDR circuit, and then the students were encouraged for the afternoon to pursue their own ideas and projects, which they brought along. So here's a few examples. So a couple of ladies who were teachers brought something that they were doing in their class at school. This is a photo of some ladies from a local drumming band who brought a t-shirt in that they wanted to modify because they wanted to make some interactive t-shirts for their drumming band. And this is Amy, who made a fascinator for an upcoming burlesque festival that was going to happen in Hebden Bridge. And the top one is a cyclops that a young man made that had a blinking eye, cyclops eye, that changed from orange to green. Although you could have long workshops or short workshops, you can fit a hell of a lot in. And I'm not going to read all these out, but I just made a list of some of the things that students had learned. And it's not because I want you to read all that, but I just wanted to show how massive amounts of knowledge you can share and enthusiasm for hardware and coding in just a short time. So I thought I'd end with just, for those who might want to do their own workshops with young people or anyone, I just put together some summary tips for planning workshops. So when I'm writing a workshop, I follow the following kind of guidelines. So I think, well, who's it for? Who is the audience? What would they like to do? What are the aims and outcomes? You know, what do you want to achieve by the end of the class or the workshop? Why are you going to teach something? The timings, it's really important to make sure that you keep an eye on the timing, because you want to get through the whole workshop without missing any components out. The preparation, buying the kit, what do you need to do in terms of getting a venue together, setting up, example, and what do the students need to do? So there's often some preparation for the students involved. So one of the biggest things is getting the IDE actually on their computers, because if you're bringing a load of students in and you ask them to bring their own computers, it's a real nightmare. If they've got like 4 or 5 different OSs, and they're all kind of from different eras as well, and they all need a different version of the IDE, it takes a hell of a lot of time. You can spend a whole morning doing that. So preparation up front. And do the students need to bring stuff themselves? So if you're asking them to make their own kind of project at the end, or spend time, get them to bring something that they're interested in. Otherwise, you know, it's always good to involve their own interests. Otherwise it can fall a bit flat. Always test your code and your circuit. So don't go and buy a load of kit and then expect it all to work on the day. Try out your circuit. Think of possible issues. You know, are some people shy? Are some people going to raise their head, etc.? And do you need helpers? Because if you've got a bunch of kids or beginners, you really need, you'll end up with lots of hands in the air. So it's always good to have a few helpers. And evaluation, always do a Q&A on your workshop. And on the day, get there early, do your preparation in terms of get all your power blocks sorted out, etc., and your projector really early, because once people start coming in, the buzz is going to grow, and you want to keep that going during the day. Do an introduction. I always do an introduction on wearable tech to give people a bit of inspiration. Stick to the schedule. Don't go off on tangents, and don't forget to have breaks and lunch, because sometimes you can get really enthusiastic and forget to have a cup of tea, and then when people start to flag, you know, it's really hard to get the momentum going again. Encourage experimentation. You want people to make mistakes and enjoy themselves. So encourage them to change the code and fiddle about and pull things out and plug it in. Get them to learn through making mistakes and having fun. At the end of the day, recap what you've done, and so everybody, you know, just has a little bit of a refresher of what you've learned through the day, and do a quick show and tell as well. So it's always great to get people up to say what they've learnt during the day and show, and have a list of further reading. And as a tutor, do enjoy it. That's it really. Has anyone got any questions?